In this video, we're going to learn about absolute value graphs. In algebra, the absolute value of a number represents the distance of that number from 0 on the number line. It's always positive or 0, regardless of whether the input is positive or negative. For example, the absolute value of 5 equals 5. And the absolute value of negative 5 also equals 5, because both numbers are 5 units away from 0 on the number line. Let's take a moment to make the parent graph of the absolute value functions. We'll start by filling out this table for the equation y equals the absolute value of x. Well, the absolute value of negative 3 is positive 3. The absolute value of negative 2 is positive 2, and so on. Notice we're not always switching the sign. Positive numbers stay positive when we're working with absolute value. Let's put these points on our graph. And we end up with a V-shaped graph. Here we have the graph of the absolute value of x in Desmos, and let's take a look at what happens when we change this equation a little bit. If we graph y equals the absolute value of x plus 3, we notice that the graph moves up 3. And likewise, when we graph y equals the absolute value of x minus 5, the graph moves down 5. So when we add or subtract a number to the parent function, the graph just moves up and down. It changes the y-intercept, or it changes the location of that vertex. Something a little different happens when we try to move the graph right and left. When we add 3 inside the absolute value bars, we notice that the graph doesn't move right, it moves left. The vertex moves from 0, 0 to negative 3, 0. So inside the absolute value bars, it doesn't work exactly how our common sense would hope it would. And notice once again, when we subtract 4 inside the absolute value bars, the graph moves right 4. Let's combine those two ideas and graph y equals the absolute value of the quantity x plus 6 plus 7. So this plus 6, that's actually going to move the vertex left 6. And the plus 7 will move the vertex up 7. So I'll start by moving the vertex left 6 and up 7. And then I'll make my v by going over 1, up 1. So now the vertex is at the point negative 6, positive 7. Let's investigate how a negative sign in front of the absolute value affects the graph. When we graph y equals the opposite of the absolute value of x, we notice we just get the same graph, just reflected upside down. So when we graph y equals the opposite of the absolute value of x plus 4 minus 3, well, we know we're going to move the vertex left 4, kind of opposite of plus 4, but then we move it down 3. And then we also flip the graph upside down. So I'll start by moving my vertex left 4 and down 3. And then make my v. And then, to account for the negative sign in front, we need to reflect the graph upside down. So there's my graph of y equals the opposite of the absolute value of x plus 4 minus 3. Let's investigate now what happens when we put a number in front of the absolute value. So right now we're looking at the graph of y equals the absolute value of x. And now I'm going to graph y equals 3 times the absolute value of x. And we notice, instead of going over 1, up 1 for the first move, we go over 1, up 3. So it's 3 times steeper. Likewise, if we put a fraction in front, y equals 1/2 times the absolute value of x, well, we notice it goes up half as fast. Instead of going over 1, up 1, it goes over 1, up 1/2. So now let's graph y equals 2 times the absolute value of x plus 4 plus 2. I'll start by locating my new vertex. I need to move it left 4 and up 2. I think I'll start by making my irregular b. Now we also have this 2 here. That means the first move is going to be twice as steep. So instead of going over 1, up 1, it's over 1, up 2. So there's my graph that is twice as steep. The vertexes move 4 units to the left and 2 units up. I hope these examples have been helpful. This is Mr. Ela, signing off.